So for our problem, we chose a snow cone with a height of 6 inches and a radius of 4 inches being filled up with crushed ice at a constant rate of 1 cubic inch per second. For the first problem, find the volume of ice in the cone when h equals 2 inches. So for the first part, you need to find the volume when the height is equal to 2 inches. Starting with the volume in the formula for the volume of a cone, which is V equals 1/3 pi r squared h. R is equal to 2/3 h, because h is equal to 6 inches when r is equal to 4 inches. By plugging h into r in this equation, this simplifies to V equals 1/3 pi times 4/9 h cubed. When h equals 2 inches, the 2 is then plugged into that equation, so V equals 1/3 pi times 4/9 times 2 cubed, which simplifies to V equals 32 over 27 pi inches cubed. For the second part, determine how fast the ice level is rising when the ice is 2 inches deep. For the second problem, first find the derivative of the volume equation. The derivative of the volume equation is 1/3 pi times 4/3 h squared times dh over dt. From there, use the given dv over dt is equal to 1 cubic inch, then plug in the height which is given, which is also 2. From there, simplify and solve for dh dt to find that dh over dt, which is the change in height, is equal to 9/16 pi. Using the rate above, find the rate of change of the radius at h equals 2 inches. For the final equation, we need to find the rate of change of the radius at h equals 2 inches. First, use the ratios found in the first equation to find that r is equal to 2/3 times h, and then when h equals 2, that r is equal to 4/3 inches. Then, use the volume formula and find the derivative, finding that dv over dt is equal to 1/3 pi times 2r times dr over dt times dh over dt. From there, plug in the givens and the other information which we already know from previous equations, including dh over dt equals 9 over 16 pi, r is equal to 4/3, and dv over dt is equal to 1 cubic inch. From there, solve for dr over dt, and find that dr over dt is equal to 2 inches per second.